Hello, this is Thzom Wilson with Giant Pacific Octopus Amusements. And today I'm here to bring you a demonstration of a program that I wrote. It's a natural model of a predator-prey relationship as far as their populations go. It's originally based on an old Scientific American article from 1984 about a world called WA-TOR, because the world is shaped like a toroid, and the entire planet is covered with water. And it's only populated with fish and sharks. Now, I've deviated enough from the original description that I don't call this application WA-TOR. I call it fish, sharks be fish. So what you're seeing here is two species. The sharks represent the predator population. The fish represent the prey population. And they're swimming about the sea, doing what they do. The sharks eat the fish. The fish make more fish. And we study their populations on the bottom of the screen via some graphs. Now, there's a lot of science kind of behind this, and if you read my documentation or the original article, you'll learn a lot about the science behind it. But I think my real motivation was twofold. One is anytime I want to learn a new programming language, I tend to code up a version of this. This particular one is written in C#. I wanted to learn C#, and I like to have a goal so that I can solve problems as they come up and learn the language. Now, what we can do here is we're controlling several parameters that can drastically affect how the populations relate to each other. Down at the bottom, you'll see that there are three life parameters. There is fish breed time, and that is basically how many moves a fish makes, or roughly how many a fish makes, before it spawns a new fish. The sharks have a similar parameter, shark breed time. So every couple of moves in this particular case, the shark will have a baby. Now, let me change the simulation time on this because I see it's ending by itself. So the final parameter is the shark starve time. The sharks must continue to eat fish to survive. And if a shark goes roughly 7 moves without eating a fish, it will die. You can tell the health of the sharks really by looking at their color. When they're orange or turning orange, they're happy, they're hunting, they're eating. If they go without food a while, they start to fade away, and eventually they die. The original simulation was pretty rigid, and there were very few controls. You basically set a bunch of numbers and let it go. Now, I've coded this quite a bit differently because I really wanted it to be kind of a visually stimulating thing that's fun to watch. So that's why it's got like some natural timing to it, where like it'll refresh itself with new parameters. Can even change the size of the sea over time. There's a lot of color cycling, and it really looks good actually on a 1080p TV set. So I'd recommend downloading it and giving it a try. So let's see some of the things that we can change. First of all, I want to point out that like any good Windows program, if you hit F1, you will get help, and that will tell you quite a bit about what the commands are. The parameters are all done with the cursor keys, and you can change them in real time, unlike the original simulation. So if things don't look like they're going right for one of the species, feel free to jump in and fiddle with some of the numbers to help them out. So help off. And let's look at some of the things that we can set here. Now, so far these numbers seem to have worked out pretty well. But what can happen is we can run out of fish, or we can run out of sharks. The relationship that this proves, and you can see somewhat in the graphing, is that the population levels are related. So when there's more food, the sharks are healthier and they have more babies. And of course, as their population grows, they start eating the food and the prey or fish population declines, which leads to shark starvation. The fish react to that when there's less sharks by breeding again, and you start getting these sine waves. Now, nature is actually much more complicated. There's a lot more inputs than these three things. But you will see population fluctuations that resemble out-of-phase sine waves, as you're seeing here. So let's fiddle around with some of the things. First of all, let's point out you can change the speed of the simulation. And sometimes it's fun to just watch it in slow motion. Here it is at 1/4 speed. It goes all the way down to 1/8 speed. And you can really see the fish having babies, the sharks having baby, the color cycling happen as the hunt goes down. And likewise, we can actually speed it up because sometimes you want to know what's ahead quicker than you want to wait for it. You can go all the way up to 8x speed. So that one was set for 3 minutes, so it's done. But if we pick some other numbers, we're going to find out our populations are less successful. So let's put it in the mode that it's really meant to be, which is random. And random 1 will randomize the life parameters with every new sim. Random 2 will also change the size of the sea. I will say that larger seas hold more creatures and they're more likely to be stable with a given set of parameters. There's an example right there. All the fish were eaten, and so that is the end of the simulation because the sharks would soon follow in death. There's some pretty unstable numbers right there. That lasted 11 seconds. Let's get our sim speed back down to a sane amount, though. This simulation will really run forever. It's meant to be automatic and really you can just let it keep coming up with new numbers and watching and see what they do. Or you can turn the randomness off and dial in the numbers and time you want. You can set it to anywhere from 1 minute per simulation all the way up to 5, 10, 30, 60, and infinity. And now infinity basically means it's going to run forever if they're stable parameters, or until one of the species becomes extinct, which is the definition of failure. So let's, I want to point another thing, like for geeky stuff, there is a debug mode if you hit the D key. This is more for programmer stat bit. I'm always interested in the frame rate and how many milliseconds there are to render an entire frame, given that it's using C# and Microsoft XNA Game Studio. I was actually pretty happy with the performance. But this tells me how many sprites are on the screen. This is all done with 2D. All the animation is done with color cycling. Effects are the blood that you see spawned when a shark eats a fish. But let's see what happens when we change some of these numbers. So let's make the sharks breed real often. Oh, look at that! I ate all the fish. Okay, so those numbers didn't work out. Now let's make them breed a little less often. Let's make the fish breed real often. And let's make the sharks real good at hunting. In other words, they can go a long time without eating. Turn our debug off. So the sharks are very happy that the fish are so willingly breeding like this. You can see that their populations just go crazy. And this kind of can point out the paradox of what you think is going to happen. You may think it's actually beneficial for the fish to breed real often, but that can backfire because it creates a lot of food for the sharks, which in turn helps their breeding to the point there can be so many sharks they just come back and eat you. Now in nature, these populations have been around a long time, and the numbers are much more stable and not so subject to disaster like some of the numbers you can come up with here. By the way, you can pause it at any time with the P button. Another thing you can do is keep the same parameters but change the size of the C. So let me make a small C, which is much less likely to be stable. There we go. We got larger fish to fill them. And this will run forever, as you can see by the parameters. The most stable populations tend to be the large size C, and that's one of the things that will randomly change between cycles. So let's just see if this one survives. It's looking okay right now. I don't know how many sine wave cycles it can go through. I see some of the populations are getting dangerously low. Let's take these same numbers and apply them to the big ocean. So I'm going to hit the number 3, which is a large size ocean. By the way, I don't have to wait for these screens. If I hit spacebar, I can jump right into the next simulation. Sometimes you can get situations where the population gets dangerously low, and there can just be 1 or 2 hangers on, and they can come back and survive, and it's fun to cheer for them sometimes. So this is the medium-sized C. Again, it's meant to be visual stimulating and maybe even kind of relaxing. So sometimes I like to put it in the slow motion mode and watch it like that. So if you read below, you'll find some information where you can download this from. It is for PC only, and you can either install it right into your start menu or use the loose files via Windows Explorer, as long as you install the required components manually. It's all described in the documents. Okay, so let's say happy fishing and happy hunting. Over and out.